Right now, traveling toward you at the speed of light is a message. Not a signal, not a transmission, not something sent deliberately by any intelligence. Just light. Ancient light. The oldest light ever captured by human instruments. Light that began its journey before our planet existed, before our sun ignited, before the Milky Way had taken the shape we recognize today. Light that left its source when the universe itself was barely 300 million years old. To put that in perspective, the universe is 13.8 billion years old today. This light has been traveling for over 13.5 billion years. And when it finally arrived, when it fell onto the golden mirror of the James Webb Space Telescope floating silently in the dark of space, it carried with it something nobody expected to find so early: a galaxy. Not a wisp of gas, not a proto-galactic cloud still finding its shape. A galaxy, with stars already burning, with structure already forming, with a story already well underway. Its name is JADES-GS-Z13-0. The oldest and most distant galaxy ever confirmed by human science. And its existence, the simple, stubborn, undeniable fact of it, has sent ripples through the entire field of cosmology that have not yet settled. Because finding this galaxy where it is, at that age, at that distance, with that much structure already in place, is like opening a history book and finding a chapter that the author insisted could not exist. But it does exist. It always did. We just needed an eye powerful enough to finally see it. And what we found when we looked changed everything we thought we knew about the beginning of the universe. For most of human history, the early universe was inaccessible, not just unexplored, fundamentally physically inaccessible. The light from the earliest galaxies had been traveling so long, stretched so dramatically by the expansion of the universe, that it had shifted entirely out of the visible spectrum. Visible light, the kind human eyes can see, the kind ordinary telescopes were built to collect. The light from the earliest galaxies is no longer visible light at all. It has been stretched by 13.5 billion years of cosmic expansion into infrared radiation, longer wavelengths, invisible to the naked eye, invisible to most telescopes. To see the first galaxies, you needed an infrared telescope, a sensitive one, positioned above the blurring effect of Earth's atmosphere, cooled to temperatures near absolute zero so that its own thermal radiation did not drown out the faint ancient signals it was trying to collect. You needed, in other words, the James Webb Space Telescope. Webb was designed with this specific goal in mind. Among its many scientific objectives, one stood above the others in ambition: to look back far enough to see the first stars and galaxies, to witness the end of the cosmic dark ages, to find the moment when the universe first lit up. Its primary mirror stretches 6.5 meters across, made of 18 hexagonal segments of beryllium coated in gold. Gold, because gold reflects infrared light with extraordinary efficiency, because the engineers who designed Webb chose beauty and function simultaneously, and produced something that looks like a piece of art and works like nothing ever built before. Webb is positioned at the second Lagrange point, 1.5 million kilometers from Earth in the direction away from the Sun. A gravitationally stable location where Earth and Sun are always behind it, where its 5-layer sun shield, each layer thinner than a human hair, together reducing the temperature on the cold side to minus 233 degrees Celsius, that its instruments at the temperatures required to do their work. It launched on Christmas Day 2021. It unfolded over weeks in a sequence of 344 steps, each one critical, each one a potential mission-ending failure if something went wrong. Nothing went wrong. And when Webb opened its eye fully and pointed at a tiny patch of sky, a region of space already surveyed by Hubble in a program called the JADES survey, the James Webb Advanced Deep Extragalactic Survey, it looked further back into time than any instrument in the history of human science. What it found in that patch of sky rewrote the opening chapter of the universe's story, not by finding one ancient galaxy, by finding dozens of them, each one further away than the last, each one carrying light from an earlier and earlier moment in cosmic history, each one a step further back toward the Big Bang itself. And at the very end of that chain, at the furthest limit of what Webb could detect and confirm, sat JADES GSZ 13-0, the oldest thing human eyes have ever seen. Let us talk about what JADES-GS-Z13-0 actually is. It is a galaxy, a collection of stars, gas, dust, and dark matter bound together by gravity, like the Milky Way, like Andromeda, like every other galaxy in the observable universe, except it existed when the universe was 320 million years old. For context, the universe is currently 13.8 billion years old. The Milky Way is estimated to have formed roughly 13.5 billion years ago. Our Sun formed about 4.6 billion years ago. JADES-GS-Z13-0 was already shining before most of those things existed. How do we know how old it is? Through a measurement called redshift. As the universe expands, the space between objects stretches. Light traveling through that expanding space gets stretched along with it. The wavelength increases. It shifts toward the red end of the spectrum. The more it has shifted, the higher the redshift, the further the light has traveled, and the older the source. JADES-GS-Z13-0 has a redshift of approximately 13.2. To give that number meaning, a redshift of 0 means right here, right now. A redshift of 1 means the light has doubled in wavelength during its journey. A redshift of 13.2 means the universe has expanded by a factor of over 14 since this light was emitted. The light Webb collected from this galaxy left it when the universe was 1/43rd of its current age. And that light tells a story. This galaxy is not enormous by the standards of galaxies we see in the nearby universe. It is compact. Its stellar mass, the total mass of all the stars it contains, is estimated at several hundred million solar masses. Compared to the Milky Way's roughly 1 trillion solar masses, that sounds modest. But those stars exist when they should not yet be mature. According to the models of galaxy formation that cosmologists had built and refined over decades, the universe at 320 million years old should not yet contain galaxies with this many stars. There should not have been enough time for sufficient gas to collapse, for enough stars to be born and begin fusing hydrogen, for enough stellar generations to enrich the surrounding gas with heavy elements. The timeline, simply put, is too tight. Stars were forming faster in the early universe than our models predicted. Galaxies were assembling more rapidly, more efficiently, driven by processes we do not yet understand. JADES-GS-Z13-0 is not alone in this. Webb found multiple galaxies at similarly extreme distances. Together, they form a pattern, a consistent story of an early universe that was more dynamic, more productive, more structurally complex than the models allowed. The models are being revised now. This is not a crisis, this is science doing what science does. But it means that the story of the universe's beginning, the story we thought we knew, is being rewritten, page by page, galaxy by galaxy, one ancient light at a time. And somewhere in the gaps between what the models predicted and what Webb actually found, the real story is hiding, waiting to be understood. The discovery of JADES GS-Z13.0 is not just a record, it is a key to unlocking questions about the early universe that have been among the most fundamental in all of cosmology. One of those questions is the epoch of reionization. After the Big Bang, the universe cooled and neutral hydrogen formed. The cosmic dark ages began, that vast, formless, lightless period before the first stars ignited. Then, the first stars were born and began pouring ultraviolet radiation into the surrounding gas. That radiation was energetic enough to strip electrons from neutral hydrogen atoms, to ionize them. The fog of neutral hydrogen that had filled the early universe began to clear. The universe became transparent to light for the first time since the very earliest moments after the Big Bang. This process, the epoch of reionization, reshaped the entire universe. It is what allowed the cosmos to become the transparent, galaxy-filled, light-flooded universe we observe today. But the details of how it happened, which sources provided the ionizing radiation, how quickly the process occurred, what the first galaxies contributed, have been difficult to pin down. Jade's GS Z13.0 and the other galaxies Webb found at extreme redshifts are candidates, active participants. Galaxies whose young, hot, massive stars were pumping ultraviolet radiation into the surrounding gas at precisely the epoch when reionization was getting underway. Every measurement Webb makes of these ancient galaxies contributes to the picture. The star formation rates, the stellar populations, the chemical composition of the gas, the presence or absence of dust. Together, they paint a portrait of a universe in its most turbulent, most generative, most chaotic phase. A universe still deciding what shape it wanted to take, still building its first large structures from the raw material of hydrogen and helium and dark matter. And there is another question Jade's GSC 13.0 forces us to sit with. Dark matter. We cannot see dark matter. We cannot detect it directly with any instrument yet built. We infer its existence from its gravitational effects, from the way galaxies rotate, from the way light bends around galaxy clusters, from the large-scale structure of the cosmic web. But dark matter is the scaffolding. In the leading model of cosmology, dark matter collapsed first. It formed invisible halos of gravitational potential. And into those halos, ordinary matter, hydrogen and helium gas, fell and accumulated and eventually formed the first stars and galaxies. If galaxies formed faster than the models predicted, then dark matter must have clumped faster too, must have built its gravitational scaffolding more efficiently than the simulations showed. Which means our understanding of dark matter, already incomplete, already one of the great outstanding mysteries of physics, needs refinement. Jade's GS Z13.0 is not just the oldest galaxy ever seen. It is a test of our understanding of the invisible substance that makes up 85% of all the matter in the universe. And so far, it is suggesting that we have more to learn than we thought, which is, when you think about it, the best possible outcome. Because a universe that still has secrets is a universe that still has questions, and questions are what science runs on. The light from Jade's GS-Z13-0 left its source 13.5 billion years ago. At that moment, there was no Earth, there was no Sun, there was no Milky Way in anything like its current form. There were no planets, no oceans, no atmosphere, no life of any kind anywhere in the universe as far as we know. Just a young, compact, furiously star-forming galaxy in an early universe still figuring itself out. That light set off on its journey. It traveled through the expanding cosmos, through the slow formation of the first large-scale structures, through the birth of our Milky Way, through the ignition of our Sun, through 4 billion years of Earth's geological history, through the emergence of life, through the evolution of creatures that eventually developed eyes, and then curiosity, and then science. For 13.5 billion years, it traveled. And then, on a specific date in 2022, it fell onto a golden mirror floating in the cold dark of space, 1.5 million kilometers from a planet that had not existed for most of the light's journey. And it was caught, focused, dispersed, measured, analyzed. And in the data it carried, in the specific wavelengths of infrared light, in the precise redshift, in the spectral signatures of hydrogen and other elements, the light told its story. Told it to creatures who had built something extraordinary enough to listen. There is something almost sacred about that moment. Not religious, not supernatural. Sacred in the way that any act of genuine understanding is sacred. In the way that decoding something ancient and real and previously unknown to anyone feels sacred. We looked at a galaxy that formed before the Earth existed and we measured it. We determined its age, its mass, its distance, its chemical composition. We placed it in the timeline of cosmic history and understood what it was doing there and why it matters. That act of understanding connects us to something almost incomprehensibly vast. The universe is 13.8 billion years old. For almost all of that time, for the first 13.79 billion years or so, nothing in it had the capacity to look back at its own history and understand what it was seeing. The universe existed, it evolved, it built its galaxies and its stars and eventually its planets, but it did not know itself. Then life appeared, then intelligence, then curiosity, then science, then telescopes, then space telescopes, then a golden mirrored machine unfolding in the dark 1.5 million kilometers from a blue planet, cooling itself to near absolute zero, waiting patiently to catch ancient light. And the universe, for the first time, began to see its own beginning. JADES-GS-Z13-0 is the furthest back we have ever looked. It will not remain the record holder forever. Already, Webb is searching for galaxies at even higher redshifts, even older, even closer to the Big Bang. Candidates have been identified. Confirmations are pending. The record will fall. But something about JADES-GS-Z13-0 will remain. It is the galaxy that at this moment in history stands at the edge of everything we can see, the last outpost of the observable universe. Beyond it, in the direction of the Big Bang, lies a darkness our instruments cannot yet penetrate. A darkness not of absence, but of limit, the limit of our reach. For now. And reaching, always building better eyes, always pointing them at the darkest and most distant corners of the cosmos and asking what is there, is the most human thing there is. The oldest galaxy ever seen waited 13.5 billion years for us to find it. We got there eventually. We always do.